One of the hardest parts in pretty much any question is trying to work out what the question is asking you to do. And we know how to do things, but then the question seems somehow very confusing. So in this one, take some time and break it down. The coefficient of x cubed in the expansion of 3 plus 2ax to the 5. Now we know how to do binomial expansion, so we should be able to find the x cubed term if we expanded those brackets. Then we're told, well, that coefficient, that's the number before the x cubed, is 6 times the coefficient of x squared in the expansion of 2 plus ax to the power of 6 in brackets. All right, so if we just think about that for a bit, we go, well, I need to find a term from the expansion of the first brackets. I also need to find a term from the expansion of the second brackets. And then the coefficient of the one I find in the first brackets is 6 times the coefficient of the one I find in the second brackets. All right, so why can't we do that? Well, we can. And so to do a binomial expansion, and you don't have to do the whole binomial expansion, you just have to identify the term that is required, which is the x cubed term. Now, if we were to do the whole expansion of the 3 plus 2ax to the power of 5, we would do it like this, where the first term you go 5c0, and then inside the brackets the 3 is the first term, so it's 3 to the 5, and then the second part is the 2ax raised to the power of 0, but of course that's going to be 1. And then you create the second term, 5c1, and then 3 to the power of 4, 2ax to the power of 1, 5c2, 3 to the power of 3, 2ax to the power of 2, and so on. You just keep going, where the powers on the 3 go up by 1, the powers on the 2ax, or other way around. The powers on the 3 go down by 1, and the powers on the 2ax go up by 1. All right, so as I said, we don't actually have to write the whole thing out. It takes a lot of time. We just have to identify, if we can, which one is going to make the term that I want. Now, some key things to notice here are this. The 5c0, that 0, well, the 5 is always the same in every one, but that 0 kind of mirrors the power of the second term. It actually doesn't matter if you use the first term power or the second term power, because you will get the same result. But, you know, the way that we learn, oh, it's 5c0, it's the second term's power. And the other thing to notice about the two powers that we use on the first term and second term, well, they add to the power on the brackets. It was 5, and so 5 plus 0 is 5, 4 plus 1 is 5, and 3 plus 2 is 5. Right, so knowing those two things, it's fairly easy to find what we want. We look at it and go, well, what makes x cubed? And we go, well, you have to take the 2ax and cube it. And if we did that, we go, oh, well, that's going to make the x cubed. Well, what about the other term in the brackets? Well, that's the 3. And so what do we have to do to that? Well, the powers have to add to 5. So if I'm cubing the 2ax, I'm going to square the 3. All right, well, what about the combination, which is out the front, 5c something? Well, just use the power on the second brackets, which is 3. So 5c3. Okay, and that's the term that we want, which is great. Now we run into the next hurdle that we have to try and solve, and that is, what's 5c3? That's a combination, right? Well, we did learn that it is in Pascal's triangle, and you can draw the triangle if you want, and to do that you create this lovely structure until we get to the row which has got the 5 in the second place. The first number is always 1, and then the second number, 5, is going to be well, the same value as the first number in your combination there. And so we get 1, 5, 10, 10, 5, 1. And that corresponds to 5c0, 5c1, 5c2, 5c3, 5c4, and 5c5. So we can just read the number out of the table and go, well, 5c3 is 10. Right, easy. There is another way that we can do it, right? If you didn't want to write the table out, or actually, if we're dealing with really large numbers, so we're not dealing with 5 anymore, but we're doing like 22c18, and it's well, you wouldn't write the table to 22 rows. It's way too much work, and so we would use the factorial notation, where 5c3 is equal to the 5 factorial divided by the 3 factorial 2 factorial. Now that's actually not too hard to solve when you remember 5 factorial is 5 times 4 times 3 times 2 times 1, right? Well, it seems confusing, but we're dividing that by 3 times 2 times 1 multiplied by 2 factorial, which is 2 times 1. And when you have factors everywhere, you can cancel factors from the numerator and the denominator, and a lot of things cancel here. Well, first of all, you can cancel the 3, 2, and 1. Well, we don't really have to worry about 1 because 1 times anything is itself, so let's just ignore it for now. But then we have the 2 as well, and on the denominator, and we can cancel that with the 4 on the numerator to make 4 divided by 2 is 2. And we just have 2 times 5, which is 10. So that also gives us the value that we need for 5c3, which is 10. All right, so then if we keep going, we've got 3 squared is 9, and we have 2ax in brackets raised to the power of 3. So 2 to the power of 3 is 8. A cubed is a cubed, and x cubed is x cubed. All right, if we put all of the coefficients together, we get 10 times 9 times 8, 720, a cubed, x cubed. And our coefficient is the 720 a cubed. All right, so the next part, let's just go straight to the term that we want, which is the 2ax to the power of 6 in brackets, but we want the x squared term, so let's do what we did before. This doesn't equal what I'm writing, because it should equal the full expansion. So I'm going to say I'm just going to lead to. And what we have is, well, I want the squared, so let's take ax and raise it to the power of 2, which means if we go back, the 2 has to be raised to the power of 4, because they have to add to the 6. And for the combination, we have 6c, and remember, it's the power. It doesn't actually really matter because the table is symmetrical, so you're going to get the same value irrespective. But let's go power of 2 because by convention that's what we do. All right, so that gives me 62. Now, how do I find that? Well, I can go to Pascal's triangle, but doesn't go to the row of 6. Well, we can add it if we want, right? So it'd be pretty easy to add it to what we have. 1, 6, 15, 20, 15, 6, 1, and 6c2 is 15. Or, of course, you could do the combinations to work that out as well, and you'd get 6 factorial over 2 factorial, 4 factorial. The 4 factorial is going to wipe out the whole tail of the 6 factorial, right? And just leave you with 6 times 5. And the 2 factorial is just 2 times 1, but we don't need the 1, so just divide by 2. 2 divides into 6 gives you 3. 3 5s are 15, and so we get 15 that way as well. So we have 15 times 2 to the 4 is 16, and then we have a squared, x squared, which means the coefficient, 15 times 16, 240 a squared, x squared. The coefficient, of course, is just the 240 a squared. Now, if we go back to the question, we're told that the first coefficient is 6 times the second one, so 720 a cubed is 6 times 240 a squared. From there, we're just solving for a. Divide a squared from the second side into the first side, bring it over to the first side, and you've got a cubed divided by a squared. And then take 6 times 240 is 1440, divide it by the 720, and we end up with, well, a cubed divided by a squared is just a, and equals 2. And that's it. So we're done. So while it was a complicated, sort of confusing question, the parts of it were not beyond us, and all we had to do was take our time, try and think about what they're asking, and then work out what each part does.